Okay, guys. Uh, it's funny. Welcome. Today we start a new topic. I believe this topic will help you a lot to work in the project. Okay, we have a lot of things to do, but the dynamic is the same. We start with teaching theory part. After I change a little the way to teach the lab and follow you work. Okay, give me a second. Okay, just a second. Okay, no problem. No problem with Alejandro, no problem. Again, today we teach about the edge layer. Okay, we start to work in the Node-RED. I prepared the class in three parts. The first part, I will make the theory part to explain what is edge, the service that edge needs to provide. The second part, I will show the Node-RED, show how to use, explain the main concept. And the third part of the class, the third and the fourth, you have time to realize a little more difficult exercise, okay? Before I start, did you have any question? Have any questions about anything?
Not yet.
Okay. Send me the messages. I have a question. It's not exactly a question about the Alejandro, you play soccer or American football?
Soccer.
Oh, it's a soccer. Okay, amazing.
Yeah, thanks.
Okay. Okay, give me a sec. My little lost. Where is the things? Okay, now I got. Okay, again, one more thing. At the end of the session, I will show how to use my simulator in the Node-RED, okay? But I believe it's much better to explain the Node-RED first and after explain the simulator. Okay, guys? So if I'm recording or not? Yes. Okay. Today we start the edge part, okay? The idea is to introduce you the edge, and at the end of the session, we understand how the edge works, the main concepts, the main protocols, and we will really understand how to use Node-RED to configure one. Again, I prepared a lab to work today, okay? And tomorrow I will prepare a challenge. The challenge is not great, okay? But you do the same thing, but not use the Node-RED, but use a cloud service to do this task, okay? And it's not compulsory to work in the challenge, okay? It's only for the guys that want, okay? And the idea is to provide some knowledge about how to work in the cloud, okay, with the cloud tools, okay? I prepared this extra exercise tomorrow, and I submit tomorrow. I publish tomorrow, okay? Again, it's not a compulsory task, okay? It's an add-on task, an extra task. For if you want, you can do, okay? So the first part is understand the IoT edge. Just only remember, the edge layer is the layer between the device, okay, the device and the cloud. Okay, this layer it is exactly provide the service to connect the device world with the cloud. One important thing is you can use directly protocols to connect the edge, Or if you have, for example, in the industry, you have a very old legacy protocols that does not support, for example, to connect, for example, this protocol a lot of times does not use IP, use another address protocol. And because of this reason, you need to have a proxy, okay? One type of proxy is the OPC, okay? We didn't study this part here because it's only related to the industry, okay? It's not to general IoT, it's only to industry IoT, okay? It's the reason that we didn't study OPC. I'll suppose in our course that you have a smartphone or device that support IP, okay? And it support IP, you connect directly to that. You don't need to have a proxy, OPC proxy to translate the message from your device to the IoT network. So again, you have the edge, and the edge is provide a group of service to the device here, okay? And one important characteristic of the edge device or the edge gate is that it is close to the IoT device. And because it's close, you have better connections, quality of link, you have bigger bandwidth, and you have big bandwidth, and you have smallest, is bigger throughput and smaller delays and error rates, okay? Because here you have, for example, think that the edge device is installed in the campus or in a building, okay? Things you have, for example, in the technology Monterey, you have a very large IoT network, okay? And you have a cloud, and the cloud maybe the cloud is in the Google or in other place, and your device is very hard, for example, to have a connection. It's not secure to have a connection direct to the cloud, and it's the reason to put the edge gate. And the edge gate is exactly provided gateway service to this device, and it's closer to the device. For example, if you think about the Technology Monterey Cidade de Mexico City campus, you have if you install one network like that, you have an edge device there. If you have another network, IoT network in the Santa Fe campus, you install another edge device in the Santa Fe campus, okay? Any questions you hear, guys?
No.
Okay. This layer has 3 components, okay? The edge tools, the edge computing, and the edge gateway. We'll explain these layers now. The gateway is the core and is responsible for forward data from the device to the data hub. The data hub is the entry point of the cloud, of IoT cloud, okay? You have one entry point, the name is IoT, the name is the IoT data hub, but it is located in the cloud. The edge is the device that provides the forward message from the IoT device to this hub. The second one is the tools, okay? The tools are utilities for configuration, log management, and patching, okay? It supports, for example, the device managed that is located in the cloud, okay? You have in the cloud a service that manage the endpoint device. Okay, for example, you have a database where you have all IoT device, and you have a lot of features inside. For example, you check. For example, if you receive a new update for one device, for example, if you the company that developed the device generates a new update, you receive this update, check with device you need to receive this update, and send the update to the edge. Okay, and the edge will apply the update. Okay, and you have the edge computing. The edge computer provides a group of service like you have in the cloud, but in the small scale. For example, in the edge, you can use, for example, very powerful machine learning models, for example, to classify, to identify anomalies. Okay, and in the edge gateway you have in the edge computing, you have a small scale of what you have in the cloud. For example, in the cloud you support to manipulate, for example, millions of nodes. In the edge, you manipulate thousands or maybe hundreds of nodes. Okay. It's a little main architecture. In the app, you have the edge tools, you have the console, auto registration, cybersecurity patch, auditing, logging, and configuration. And again, it supports the work of the device manager that is in the cloud. You have the gateway. In the gateway, you have the adapters. For example, things that you use OPC, you need to have the adapters of OPC. And you have the storing forward. Remember the explanation about the storing forward? You receive, you store for a moment, and forward to the destination. Okay? And you have IoT adapters. IoT adapters is IoT. Industrial adapters is connectors that provide to the edge capability to understand old legacy protocols like OPC, and IoT adapter talks the directly IoT protocols. Okay, and in the edge computing, you can develop one model. You have analytics and actions. So the most important component is the gateway. Okay, the gateway is the core of the edge. Okay, if you have the edge device, the core is the gateway. Okay, at least you have implemented in the gateway in the edge device the gateway. Okay, the main responsibility, as we already told, the main responsibility is to connect the device with the IoT hub. Okay, through what? Through a group of specific IoT protocols. Okay, MQTT, co-op, HTTPS, it's not specific, it's general, or AMQP. The most important component in the gateway is the IoT adapter that transfer data and forward it to Data Hub. The gateway is important because it has the ability to transfer or to manipulate different data sources based on legacy protocols using the industrial adapter. It gets the data from the OPC, for example, and transform this data, insert this data inside the MQTT message and send to the cloud. Another thing that the gateway is able to establish a secure channel and provide security to the device. Okay, remember the gateway maybe it's in the place that separates you and the cloud. Okay, and the gateway can be installed inside the gate, the file, for example, and provide secured service to IoT device. Send data to the hub, I already told. Storing forward, okay? And it's very important because it avoids that you, when you have instability in the internet connection, you didn't lose message because you store locally and forward the message. If you didn't receive, for example, any confirmation, you can send again. The edge tools, again, is more related to the device manage, okay? It's more related to the activity. It's a set of functions that support the device manage. For example, manage and configure data acquisition, define the cycles and others, has to receive patch and updates, log, browse and train the data, self-configuration, self-register, and receive and execute commands, okay? Finally, you have the edge comparing. It is the IoT middleware. It holds custom application. You can develop an application and install inside the edge and device. And for example, you can have a function in the edge device that check if the data that received from the device has integrity or not. Okay, if you don't have integrity, you should delete a lag. You have the same capabilities than the cloud, for example, run analytics in standalone mode, offline, or in collaboration with the cloud. However, in the cloud, you can support a very, very, very large amount of data. In the edge, you don't have this. This scale is completely different. Another important, it's not exactly, it's a important layer that is developed from Cisco, okay? And what it is nothing more than to have a third layer, a new layer between the edge and the cloud, okay? Things that you have the edge here and you have the cloud here. You create a new one, the fog one, okay? The fog layer. The idea of the fog layer is to provide an additional service, for example, analytics and others, in the company before the data cross and go to the cloud. Okay, the fog is very important, for example, to companies that has multiple sites. Things, for example, Monterrey. You have a Cidade de México campus, Estado de México campus, and Santa Fe. Okay, you can have edge device in which in the three campuses, so one in the Santa Fe, another in the Monterrey, in Mexico City, and finally the last one in the Estado de Mexico. And you have a fog that concentrates all of information from the three devices and transfer to the cloud. Until here, any questions, guys?
No, teacher.
Okay. So again, it's only the organization of the edge. Now we start to study some protocols, okay, that we use in the edge device. The first one, before I start to talk about the protocols, I would like to revise what is a protocol. This example is very easy to understand. A protocol is rules that define the communication. Things, for example, two guys, and you define a protocol that one guy introduce you, okay? For example, hi, it's like I open the connections, and after he send the message, okay, and receive, okay? But in this message protocol, if you're humans, you have open message, open talk message, okay? It's very similar than, for example, the TCP protocol. TCP is a transport protocol based on the TCP IP, okay? You have others UDP. In the TCP, you have the initialization of the communication has a protocol that defines how the node introduce you in the talks. For example, it's an example. The machine that you want to talk send a request. The target reply with the answer, and after you receive the answer, okay, I can talk with you, you send message, okay? This process, you will study it in the network. The name is three-way handshake. Where is my point? Oh. Three-way handshake. Okay, and it's it's three because this process is not used only two. It's not used only two messages. Okay, you use three messages. This is three steps. Okay, and the name is three-way handshake. Is the name of the set of messages to open TCP connections. Okay, again, it's not the focus of our course. Okay, we study it in the TCP in the network course. Okay, what is important for us now is understand that the protocol define whole syntax, semantic, and synchronization of communication and possible errors and recovery methods. Okay, for example, in the TCP, when you lost one message, you have a specific procedure to how to retrieve the message that you lost. The TCP IP is a protocol that is very used, that has a very big number of devices that you use, okay? But it is based in another protocol, in the OCI model. The OCI model, or OZ in Portuguese, I believe in Spanish the same, is not one implemented protocol. Okay, it's a model, it's a concept model. I remember then there are only few operating systems that implement OZ model. For example, I remember the Solaris. Solaris is an old Unix implementation that you have the OZ stack implemented, okay? But it's not common, okay? The OZ, as I said, is a model and a concept model, okay? That divide the communication in 7 layers and define that one layer, which service each layer provide, okay? The main idea is you receive the data from the cables and you process this data layer by layer until the data is in the application, and the user uses, for example, the Instagram, Facebook, and others, consume the information and present to the user. The process is the same when you use an application to send a message, okay? You manipulate the message layer by layer to be possible to inject this message in the cable, and the data is navigating to the target of the message. I have a move here. Give me a second. Just want to share my screen with audio. This video here is amazing because the video, oh, give me a second. The video is amazing because the video explains better what is the OZ model, okay? Oh my gosh.
Welcome to Cert Bros. In this video, we're going to be taking a look at the OSI model. So, what is the OSI model? The model is a theoretical stack of 7 layers that can be used as a reference to help understand how networks operate. The model was introduced to standardize networks in a way that allowed multi-vendor systems. Prior to this, you would only be able to have a one-vendor network because the devices from one vendor couldn't communicate with others. It's worth noting at this point that we don't actually use the OSI model. We use something called the TCP IP model. The concepts are exactly the same, the layers are slightly different. So if we don't use the OSI model, why would we bother learning it? Well, that's because it's still referenced a lot when troubleshooting or describing network operations. Let's take a look at the layers starting from the bottom up. Layer 1 is the physical layer. The physical layer is the lowest layer of the OSI model. Its key responsibility is to carry the data across physical hardware such as Ethernet cables. Layer 2 is the data link layer. At this layer, the physical addresses are added to the data. This is the source and destination MAC addresses. Switches are located at this layer. The network layer handles IP addressing and routing. At this stage of the OSI model, the source and destination IP address are added. Routers operate on this layer. Layer 4, the transport. The transport layer of the OSI model adds the transport protocols such as TCP and UDP. TCP, for example, is used for error handling and sequencing to ensure no data is lost. This layer also adds the source and destination port numbers. Layer 5, session. This layer is responsible for establishing and terminating connections between devices. Layer 6, presentation. This layer formats the data in a way the receiving application can understand it. This layer is also able to encrypt and decrypt data if needed. Layer 7, application. This layer is where the application and user communicates. Application-specific protocols are used here, such as SMTP, if you're sending an email, for example. A really good way to remember these layers is simply all people seem to need data processing. APSTNDP. So to fully understand how this model works, you need to see a real-world example. Let's say you send an email. The data travels through the OSI model, adding and processing data on each layer. Now this process is called encapsulation. Step 1, the application layer. Outlook creates the data, the email you wrote, the email addresses, etc., etc., and gets ready to send it using SMTP, which is the Simple Mail Transfer Protocol. Step 2, presentation layer. The data is formatted in a way the receiving device will understand. In this example, probably ASCII. This layer could also encrypt the data if needed. Step 3, session layer. A session with a receiving mail server is started. Step 4, transport. This is where it decides to use TCP or UDP. In this case, we'll use TCP to make sure every packet gets delivered. Also, the source and destination port is added to the data. Step 5, network. The IP address of the mail server is added as the destination, and the source IP address is also added to the data. Step 6, data link. The MAC address of the router and the source MAC address of the host is added to the data. Step 7, physical. The data is sent out on the network using Ethernet. So when the data reaches the other side, The receiving device will process the data in the same way but in reverse, starting from the bottom up. Okay, so that's the OSI model, but how can we use this to troubleshoot? You may have heard the term, oh, that's a layer 2 problem, or sounds like a layer 3 issue. When you hear that, that's people referring to this model. Let's say there's a problem with the network. If we go through this model, checking every layer, we can soon diagnose the problem. For example, layer 1, are all the cables plugged in? Is the network card functioning? Could it be a fault with cable? Layer 2, maybe the switch has gone bad. Layer 3, is the router functioning? Do I have the right IP address? And the process goes on and on from there. I hope you've enjoyed this video. If you have, remember to subscribe, comment, and give a thumbs up.
Okay, any question, guys? Did you understand exactly how the way that the OCI protocol, OCI model works? Okay, just so I remember, you divide the communication process in 7 layers. Each layer has specific responsibility. Okay, and when you generate the information in the app layer, in the application layer, the message is navigated through the layer by layer until the cable, and and is transported to the next device. In the next device, the data is from the cable until the application. Okay, it's the general idea. This idea enable that we will have different providers for network technology. Before the OSI model, you have only, for example, you have the IBM. The IBM provided, that time is in 1980, provide the computer, the network device, and the application. You cannot have different, for example, you cannot buy a computer from one client, one provider, a network from another provider. No, you need to buy everything from the same provider, because you don't have all the protocol is proprietary, and there is no specification, open specification. For example, if you bought a computer from Citrix, you need to buy everything from Citrix. Okay, after the OSI is an open protocol. If you are the network provider, you can follow the standard and provide only a device that has service in the networking, for example, a router, switching, and others. Okay, if you develop only application, you can develop only application. You need only to follow the standard. The standard. Okay, it's the main. It's a very important. Okay, again, the OSI model is not, you don't have any implementation of it, but you have, for example, TCP/IP. The TCP/IP follow the OSI model to generate an implementation protocol. TCP/IP is an implementation. You'll find, for example, in your computer, we talk using the TCP/IP. Okay, but TCP/IP has little difference. Okay, for example, the TCP/IP don't have 7 layers, has a few more, few less. And for example, in the TCP/IP, you have more or less 4 layers. The physical, okay, that is not inside the TCP/IP. You have the data link. You have the networking, that is the IP. You have the transport, that you have TCP, UDP, TLS, and others. And you have the applications, okay? You don't have the session. It's not true that you don't have the session. The truth is, in the application, you have things that is related to the session, okay? Any questions? Question, guys? Or it's clear?
No, teacher.
Okay. Okay. Okay, give me a second. I'm sharing my screen.
Welcome.
Okay, think about the IoT. Oh, sorry, the Aussie model. Okay, stop. Okay, and here you have the IoT protocol standard. If you see, you have the same layer. It's not exactly the same layer that you have again. Here you have application. In the Aussie, you have application, you have sessions, okay? But in the TCP/IP, you have only the application. You have the transport, you have the network, the data link, and the physical one, okay? You can have, for example, if you think in IoT stack of protocols, you have a group of protocols in the network. For example, you have a Wi-Fi, Bluetooth, RFID, 3GPP is the 4 and 5G protocols. You have 6LoWPAN, okay? You have a network, for example, IPv6, IPv4. You have transport, okay? You have TCP and UDP. And you have application, you have HTTP, CoAP, SAP, and others, okay? Some group of these protocols cover more than one layer, okay? It's not a big issue, okay? And now we start to study only the applications protocol. We study the lowest layers late, okay? So we study today 3 of these 4 protocols. We study the CoAP protocol, the MQTT, and the AMQP, okay? You didn't study the DDS. The first one is the Constrained Application Protocol. The CoAP is an Internet Utility Protocol for restricted gags. Remember, the device in the IoT has 2 characteristics, or need to have 2 targets. Okay, okay, it's not working. When you looking for check here, it's work. No, it's not working. No, does not work. Okay, when you develop a protocol for IoT, you need to follow 2 directions. Don't consume a lot of battery, okay? You have a very low profile in the battery consumption. And the second one, you cannot require a lot of process and memory, okay? The CoAP aims to handle the very restricted gadgets, okay? It's a very device with a very low processor, very low memory capacity, okay? And the CoAP is based on HTTP protocols and use the UDP, okay? I will explain the UDP later, okay? And use UDP and the Hasper. I will explain the both now. The first is the UDP. The UDP is User Datagram Protocol. It's a connectionless communication protocol located in the transport in the OS layer, okay? You have another protocol, is the TCP, okay? And the main difference is when you use TCP, you send a message, okay? For example, you send a message and you wait for the confirmation that your message is arrived and it's correct, okay? You only send a new data when you receive this feedback. In the UDP, you only send the data, okay? If the data is you fail the process of this data, the data never arrive in the destination, the sender never knows because the protocol does not support any feedback. UDP protocol is very good when you don't have a lot of capacities, okay, because you don't need to receive the feedback, but it's very good in the real-time application. In the real time, if you lost a package is less important than you delay a lot because you need to receive the feedback. Okay. For example, application like a voice over IP, multimedia stream, like a video Netflix, for example, most of the time you use UDP because assure that the message, the stream you don't have a lot of feedbacks and your network, you use your network better. One example how to understand the TCP and UDP is like something like that. Think this example here. You have the receiver and you have the sender. In the TCP, for example, is the mother send the data, the baby, and assure that the receiver, the father, get the baby and don't drop off the baby in the ground. In the UDP, the sender just only send the baby. Okay. If the father is there or not, it's not a problem of the sender, it's the problem of the baby. Did you understand the difference?
Yes.
Yes, teacher.
Another very important protocol is the RESTful. The RESTful is an architecture model, okay? It's not exact a protocol, but it's defined the how to represent a communication between a client and a server, okay? Between a provider and a consumer, okay? Again, it's an architecture style. It's a design part of the whole API, okay? What the REST is very useful, okay? And you have a lot of use. For example, if you use the JavaScript today, most of the time you use the REST. If you use a lot of service that you have in the cloud, use the RESTful. Does not use the SOAP, for example, okay? Because the REST is light, okay? It's very light. You don't have, for example, if you use SOAP, is an alternative. The data you need to represent the data, you need to follow a lot of directions in the XML. In the RESTful, most of the time, you can represent the data and the transactions using a JSON. What you can use the XML, but you use JSON encapsulated in the XML, okay? When you use the co-op architecture, you have one server, okay? And you have the client. The client is the device, the IoT device, okay? The IoT device send the message to the co-op server, and the co-op server convert this message to the REST. The co-op server send this message to a prox, okay? That translated the co-op message to the REST message, okay? But in this case, remember, the gadget is a very low, powerful device. It's a very restricted gadget, okay? This gadget use the co-op protocol that is very, very, very simplistic protocol, okay? And you need to have the proxies that translate and, for example, provide security and provide the other capabilities to use, for example, cross the file, for example. Any question, guys? Did you understand?
Yes.
The next protocol that we use in our project is the MQTT. Okay, the MQTT is MQ telemetry transport. Okay, again, it's a very lightly message protocol designed to work in the high latency, low bandwidth, and unreliable networks, like the IoT. Okay, it consumes very little power in the device when it's running. The idea is you don't have a service. Okay, the protocol uses the publish subscribe architecture. What is the publish subscriber? Things, for example, you have one entity that publish things like a newspaper, that publish things, okay? And this publish a list of topics, okay? You can have topic one, topic two, top three, top four. For example, politics, sport, I don't know, weather, and other topics, okay? And you have the subscribers, a group of subscribers, okay? And the subscribers, what the subscriber does, they register to receive the topics of a publish, and start every time that you have an update here, and the subscriber receive this update. It's like, for example, you have an application about your preference newspaper, and you select, I want to receive the updates in my cell phone about the sport, okay? Every time that the newspaper publish a new information about the sport, you receive update in your cell phone, for example, in the SMS, okay? Again, it is the publish subscriber. You have one publish, you can have a multiple publish, that each publish one top, okay, one or more top, and you have a subscriber that subscribe for one publish and for one or more topics, okay, from one or more publish, okay. The MQTT has a broker. What is the broker? It's very hard, for example, to the subscriber connect directly the publisher, okay? Think, for example, you have a group of device, okay? Like, for example, you have a group of sensors that publish temperature, the humidity, and others, okay? And if you don't have the better approach is you send this information to the broker, and in the broker and the subscriber connect the broker, looking for each information the broker has or which topic the broker has, and talk with the broker, not talk with the publisher. The difference, if you didn't get it yet, is if you don't have the broker, okay, you share, give me a second. Okay, think that the red one is the publisher, okay, and the green one is the subscriber, okay. If you don't have the broker, what happens is the subscriber need to register in directly with each something like that. It's a very crazy situation, and very you use a lot of resources, okay? But did you understand this picture here? Yes, guys, or not? Okay. If you use the broker, okay, if you use the broker, your situation is a little different. Oops. If you use a broker, for example, the connections is a little different. Sorry. Which publisher will publish your service in the broker, and you connect the broker. The number of communications is decreased a lot. You don't have a redundancy in the using the broker. Okay. Any questions?
No.
Okay. You use the broker, you have the subscriber, the publish the information in the broker, and the subscriber looking for and the hashtag the message that you want to receive. An important characteristic in the MQTT is the quality of service. It provides a quality of service is one agreement between the device that you define the condition to provide a service. Okay. Without you have, for example, things that you have to note that assure that agree with a level of quality of service or QoS. Okay. The nodes will work to obey or to follow the QoS that you define. If you don't have, you don't need to worry about it. Another thing, the MQTT provides support definition of the QoS. Okay. The second thing, MQTT provide persistent sessions. Okay. You can save the session, information about the session, what assure that you can, in the fail of the cloud, you can analyze the data that you have locally to support and to, what I say, you save locally the information that press from the broker, and you can, in the fail of the network, you can regenerate this message and don't lose the information. Remember that this protocol this protocol is based in TCP, it's not based to UDP, okay? You have the last will. The last will is a type of message that you have to identify that is the last message. For example, you have a provider, okay? You have a publish, and the publish identify that the battery is end, okay? And in the few minutes, the device will turn off, okay? This device can send a last will, okay? What is the last will message? It's a message that identify, okay, I will leave, okay? I will disconnect in the network. You didn't receive any more message from me, okay? And it's very good because it's assure that you have a more stable network. Any questions you hear, guys? You did understand or not?
Yes.
Okay, I'm trying to find my mouse. Okay, I will give 10 minutes break, okay? I will return at 13, okay?
Okay, teacher.